Hello, everyone. My name is Jen Amann. I'm the Buildings Program Director here at ACEEE, and we're going to begin today's webinar shortly. First, I'm going to turn the program over to my colleague, Hannah Bastian, and she's going to run through some quick logistics for the webinar, and then we'll get started.
Hello, everyone. So right now, all the attendees are in listen-only mode. Following our speakers' remarks, we'll open up the webinar to questions. And then throughout the presentation, if you have a question, you can type it into the chat box, and at the end, we'll go through all the questions. Finally, this webinar is being recorded, and we will send a link to the registrants after the webinar.
Great. Thanks, Hannah. Thank you all so much for joining us today for the first in our series of Emerging Opportunities brief series webinars. I'm going to give a quick overview of the Emerging Opportunities brief series, and then I'll talk a little bit about our first brief on integrated building systems, and then we'll save the bulk of time and turn it over to our two external experts that we have joining us today to talk a little bit more about the other issues that we're covering in our series, battery storage and energy service agreements. So today we released the first 3 issue briefs in our Emerging Opportunities brief series, one on integrated building systems, another on energy storage, and the third on energy as a service. In the coming months, we'll be releasing 3 additional briefs in the series, one on window attachments, one on multi-fuel programs, and the final one on indoor agriculture and energy efficiency opportunities in that growing sector. Over time, we hope to continue to release more briefs, and we welcome your suggestions on emerging opportunities that you're looking at, things that you find exciting out in the market, and what we can do to help raise awareness and understanding of these opportunities for program implementers and others in the building industry. With each of these, we will have webinars in the future, so please keep your eye open for announcements of webinars on the upcoming briefs as they're released. So first, I'm going to jump in and talk a little bit about about integrated building systems. Integrated systems optimize building performance and efficiency gains from smart building technologies. While individual smart technologies can achieve significant savings in a given end use, as shown here, coordination through an integrated system can unlock larger whole building savings and provide the performance gains that are prized by building owners and occupants. As you can see, we estimate savings from integrated systems in the range of 8 to 18%, depending on the sophistication of the system and the number of different building components that are incorporated into the system. And we also, have a little bit of a conservative take on this. For buildings with the most sophisticated and advanced systems, savings could be higher. So there are several paths to savings from the use of integrated systems in buildings, and 3 of the main ones are data insights, fault detection, and automation. Data insights provide building operators with an opportunity to identify and analyze trends in energy use in their facilities and to identify the opportunities for efficiency improvements. Fault detection allows for detection and diagnosis of faulty performance in building systems and alerts operators to the issues so that they can be addressed. Finally, automation adjusts the system and operations to optimize performance. And this is where we see the greatest savings potential over time. Just as an example of an opportunity that comes from this type of advanced and more sophisticated controls technology, the new systems can tell you not just whether a space is occupied, as we see with traditional occupancy sensors, but also provides information on the number of occupants, allowing for much better control of lighting and HVAC requirements in the space. So key to integrated building systems are energy management and information systems. The EMIS really ties everything together. So we see EMIS as a range of opportunities, some with lower cost and lower complexity, on up to very advanced building automation platforms. More complex systems allow for greater optimization and more performance enhancements, but they do come with a higher cost and a steeper learning curve. Just as an example, our recent research shows prices for a typical cloud-based energy information system to range from 1 to 77 cents per square foot as well, but then that comes along with service contract costs. And we're seeing savings on the range of 5 to 10% whole building savings from this type of system. Moving up to higher complexity systems, building automation systems typically run from $1.50 to $7 per square foot. So we see a significant cost increment, but savings on the range of 10 to 25% are unlocked with that greater complexity in the system. One challenge for program operators and implementers that are looking to engage in integrated systems programs is the complex nature of the project and also the transactions, leading to much more complex program design requirements. Whereas a traditional lighting upgrade or other type of equipment upgrade is a one-time transaction and a pretty simple calculation of savings, energy management systems tend to be ongoing transactions, often involving service contracts over 3 to 5 years or longer. And many factors can influence energy savings in the system, depending on the state of the equipment in each of the different systems, information about occupancy, user habits in the building, and the whole range of settings for each and every one of the systems incorporated into the project. But this offers a potential for real-time tracking of energy savings and much better understanding of the true performance of upgrades relative to those in the simple widget types of program. We see program administrators promoting integrated systems through prescriptive rebates, custom incentives, service contracts, and through demand response programs. And we wanted to highlight here the program that NYSERDA is running as an example of a comprehensive offering. NYSERDA's real-time energy management building incentive program is really paving the way and providing a comprehensive approach to systems integration programs. NYSERDA engages at the vendor level and requires a 3-year service contract at a minimum. They also allow for longer-term contracts, but incentives decrease in years 4 and 5. NYSERDA has very specific vendor requirements for vendor experience, vendor capabilities, and also a long list of what the vendor is required to offer their customers and how they engage. And as of last year, 50 out of 135 applicants had qualified for the program, so it is quite exclusive. The program offers incentives directly to building owners, and as of the middle of 2018, over 175 customers had enrolled in the program, primarily commercial buildings, but also around 35 large multifamily buildings in the New York area. So I would encourage anyone to take a look at and see more about how NYSERDA is laying out their program. Moving forward, we see several needs, but also opportunities for advancing integrated system adoption in the market. Robust research and case studies are needed to confirm the savings from these systems and to address skepticism in the marketplace about the savings that can be expected and the range of non-energy benefits that can really be provided by these systems. We know that those non-energy benefits are often a driver for owners and building managers, and so being able to really show through case studies how those play out in these projects can be a really important driver. Information sharing among vendors, building owners, and program administrators can create consistency and improve offerings. That includes the offerings that are provided by programs, but also the products that service providers and vendors are offering in the marketplace. And finally, expanded participation in standard setting initiatives that are working on interconnectivity of different system components, on security, and so forth, can really help address some of the challenges and barriers that we see in the marketplace. Examples include the Open ADR Alliance, which is working on interconnectivity issues, and the Internet of Things Security Foundation, which is working on security issues. So that gives us a quick overview. I encourage you all to take a look, download and take a look at our brief that provides much more information on all of these. And I look forward to learning more over time and how you're integrating these programs into your building systems or into your program offerings.
Okay, before we go on to the next speaker, I understand that we've been presenting in presenter mode. We're going to switch the screen over very quickly, so if you can just bear with us. Okay, guys, now we're up and running. Sorry about that.
All right.
Jen can introduce our next speaker.
Great, thank you, and thank you all for your patience. Our next speaker is going to talk about energy storage in buildings and how energy storage can count as an energy efficiency measure. To discuss this, we have Todd Olinsky-Paul. He's the project director for the Clean Energy Group and the Clean Energy States Alliance. His work focuses on energy storage technology, economics, policy, and deployment. And Todd's going to talk to us specifically about what's been happening in Massachusetts and how that might serve as a model elsewhere. Todd?
Thank you. Can you hear me okay?
Sure can.
Okay, great. Well, thanks for inviting me. I'm looking forward to presenting this. This is actually the first time this work will be presented, so you're getting actually a preview of some work that we will be publishing probably at the end of February or beginning mid-March. So it's quite new, and I will be going through a little bit of background about our organization and what we do, and then we'll get right into the topic, which is energy storage as an energy efficiency measure, looking at how to value storage in terms of cost-benefit calculations for efficiency programs and other types of energy policy that requires that technologies pass a cost-effectiveness screen. And we'll talk about specifically the inclusion of storage in the Massachusetts 3-year energy efficiency plan, which was just approved last week by the Massachusetts Department of Public Utilities. So this is, again, very fresh, although we've been working on it for quite some time, and it's just come out. Next slide, please. So I want to start with just a little background on Clean Energy Group. If you could just, there you go, thank you. We are a nonprofit located in Vermont. As you can see on the screen, our work is supported by a number of foundations who generously provide us with the means to do this work. And specifically for this presentation, I want to thank the Barr Foundation and the Merck Family Fund for supporting our work in Massachusetts on this particular topic. Generally, we do a lot around storage, and that includes storage technology. We provide technical assistance to projects. Also, we provide technical assistance to states in developing policy and programs around storage and regulatory reform. We do a lot of writing and reporting and produce a lot of webinars ourselves. All that material is on our website, and I believe there's a link later in the presentation. Next slide, please. So I want to kind of set this up by talking just briefly about state policy tools for energy storage. And it's a new technology, even though batteries have been around for a long time and we have them in everything we use, you know, our computers, our cars, our flashlights, our phones, etc. But at the larger scale and for newer applications, as far as state policy is concerned, it's fairly new. And so what we're seeing over the past few years is that states are going through a sort of typical sequence or evolution of state policy, where they start with doing a study, a road mapping study, or kind of a opportunity study of the topic, just to figure out what they might want to do next and familiarize themselves with what is storage, what can it do, what can't it do, etc. Often they then will move on to a grant program to get a demonstration project or a few demonstration projects up and running so everybody can kind of look at it, test it out, see what it does, how it really works. And then they will often move on to longer term policy and programs. And this can include a broad range of policies. I'm not going to go through this list, but everything from utility procurement targets to rebate programs to tax incentives to technical assistance, etc. Part of the point that I want to make here is that we've had several states now that are early adopters go through this process. Massachusetts is one of them. And we're at the point now where I think we've started to see what works and what doesn't. And as new states begin to move into integrating energy storage into their policy suite for clean energy and efficiency, they may want to leapfrog the first couple of steps here instead of spending years doing studies and demonstration projects that have already been done in other places, and move on to some of the more effective longer-term policy and programs that support actual industry. Next slide, please. So the state policy landscape, and just to give you a sense of how this is sort of played out, as I said, everyone does studies and roadmaps first. So, you know, California, New York, Massachusetts, everybody, Vermont, New Mexico, Minnesota, everyone's done a study or roadmap to kind of, you know, at least the sort of early adopter tier states that typically look at these things earlier on. And then there's been a bunch of demonstration project grants given out in various states. It slims down from there as you go down the list. 5 states that I know of have utility procurement targets in place. A couple more have proposed them, but they're still at the proposal stage. And then beyond that, really very few. 2 states have rebates. You know, it kind of gets very slim from there. Next slide, please. So we have been working in Massachusetts for many years on clean energy policy, and working with the state energy agencies to help them put together programs and policy on energy storage. And we had proposed a storage rebate plan, very simple. And this came out around the time when the state had done a landmark study, their state of charge report, and it had recommended a whole suite of policies to advance energy storage in the state, and had established the value of that and what it would bring to the state in terms of savings. And so we proposed this to the Department of Energy Resources, and they said, well, this is great, but we don't have the money to do this right now. But there is money in the state energy efficiency program to do this, and we're right in the middle of putting together the next 3-year plan. Massachusetts does efficiency in 3-year plans. And part of the reason that money was there is because a large bulk of money that had been going to lighting was going to be freed up, because a lot of the lighting's already been changed over, and the federal standards for lighting efficiency were kicking in. Are about to kick in. So we said, okay, well, what do you need to make that argument for storage as an efficiency measure? Because as far as we know, this is not something that any state has done. putting storage into an efficiency plan. And they said, well, what we really need is something that shows that the cost-benefit calculation for energy storage is positive, that you get back more than you spend when you put it behind the meter as an efficiency measure. So we said, okay, great, and we did that. So that's what I'm really going to be presenting here. This slide, I just wanted to note the importance of this. I'm sure everyone on this call is aware of it. The electric efficiency program budgets of the states, and most states in the country have an electric efficiency program, just dwarfs any other incentive or grant program or anything that's been established to support energy storage to date. As an example, the Massachusetts Energy Efficiency Plan budget is over $2 billion. It's close to $3 billion at this point, and that is a large resource. So we felt it was very important to get storage past the required cost-benefit screen, because once you do that, the Massachusetts legislation says that that measure, once it passes that screen, should be included in the plan. Next slide, please. So we did a report. We contracted with the Applied Economics Clinic to do a report on the cost-benefit calculation for energy storage behind the meter as an efficiency measure. And this uses the same assumptions and the same methods that the program administrators in Massachusetts, those being the utilities, use for every other efficiency measure. And we published this back in July. We provided it to the state, and the result is in this table here. And the result that we came up with, we did this for low income and for commercial and industrial sectors. There's a third, which is residential, and I'll get to that. But the result we came up with was that the benefit cost ratio for low income, for storage in low income sector was 2.8. And for storage in the commercial sector was 3.4. So in other words, for every dollar you put in, for a commercial energy storage measure behind the meter, you get back $3.40 in savings, and $2.80 for low income applications. So this was a positive result, and as I said, we provided this to the state. They took it and provided it to the PAs, and after a lot of discussion and going back and forth and looking at plans and so forth, the result that came out last week from the Department of Public Utilities is that, yes, indeed, energy storage is part of the new 3-year Massachusetts Energy Efficiency Plan for the first time in the nation, as far as we can tell. And if you go to the next slide, I'll tell you what that looks like. So here's the incentive structure. This is what the PAs came up with as how to include storage in their offerings for the next 3 years as an efficiency measure. And by the way, that benefit cost information I just gave you has been superseded because they have new information that went into their latest version of their plan. So we'll get to that. So this is what it looks like. It's a 3-year plan. It's more than $2 billion. The storage measures are in a new portion of the plan called the Active Demand Reduction Program. And this is like a demand management, demand response kind of program. It includes things like thermostats and HVAC and water heaters and so forth. And so storage, battery storage is part of that program. The incentive that they're offering is for performance. It's not a rebate for installation. So in other words, they're paying for load reduction. They're not providing an upfront rebate, which we would have liked to have seen. So it is a performance incentive. New storage is eligible with or without renewable generation behind the meter. Residential and commercial customers can participate. And there's 2 programs within this plan. There's a daily discharge program and a targeted discharge program. The main difference is that, as it sounds, daily discharge has more cycling, and you'd have to respond to more signals more days of the year than on the targeted discharge program. And so the daily discharge rate, incentive rate of $200 per kilowatt hour is twice that of the targeted discharge program. Now, in actual fact, the DPU decided the daily discharge proposal needed a little more study, and so they've knocked it down to a sort of a pilot program. So what we ended up with in this new energy efficiency plan is basically the targeted discharge program. And that rate of $100 per kilowatt hour is paid on an annual basis, and it's calculated based on the average load reduction during the hours called by the utility. And those discharge hours are called in 3-hour blocks. So on any given day, you might get a signal that says, we want you to start reducing your load over the next 3 hours. And you would do that by discharging the battery to reduce the amount that you are buying off the grid. And then you, at the end of the year, those hourly load reduction amounts would be averaged, and you would get a payment based on that. The utilities are going to be offering 5-year contracts to the customer, and even though it's a 3-year energy efficiency program, they felt that they needed to do 5-year contracts. And they're also offering heat loans for storage purchases, and these are zero-interest loans that are offered as well for other efficiency technologies. Next slide, please. So here's what we think this is going to result in. The total is going to be about 34 megawatts of behind-the-meter storage installed statewide over the next 3 years. That's what we think we're going to get to through this plan, and that's over and above any other storage installed through the state's procurement target or other things. Now, the plan has some shortcomings. We think it's a very good first step. There are a few things that we would have liked to have seen. Primarily, there's no enhanced incentive or carve-out or financing for low-income customers. And in the Massachusetts efficiency plan, there are 3 buckets. There's commercial, there's residential, and then there's income eligible, which refers to the low-income portion of the plan. That's kind of a blank in this particular case. So for storage, low-income customers can still participate as residential or commercial customers, but there's no added incentive to help with this in low-income communities, which would have been, I think, good if they had done that. There's no upfront rebate, which we had proposed and would have preferred. The daily discharge proposal, as I said, was downgraded to a demonstration program, and there was a proposal by Cape Light Compact to give for free 1,000 batteries to 1,000 customers. That was not approved, and we're not sure what's going to happen with the Cape Light customers. Next slide, please. Okay, so here's an example of what that looks like for an individual customer. So let's say you're a commercial customer participating in the targeted dispatch program, which is the one that's going to be available statewide, and you install a 30 kilowatt battery on your premises. Now, because the dispatch call comes in a 3-hour block, and they're averaging your hourly load reduction to get to the incentive payment, over 3 hours, that 30 kilowatt battery is going to average out to 10 kilowatts per hour of load reduction. You then multiply that by the $100 per kilowatt hour rate to get to an annual incentive of $1,000. Now, of course, over 5 years of your contract, you could earn $5,000. If you had a ability to renew that contract, it could be $10,000 over the life of your equipment, assuming that storage lifetime is about 10 years. That's what we think it looks like. I should note that the DPU order that came out last week is a little vague on certain points. This is based on filings in the docket, and so this is what we think is happening, subject to the possibility that the utilities may tweak it a bit. I also want to note that if you are installing solar and storage, you could qualify for this performance incentive for the storage as well as the state's smart solar rebate with a storage adder, which is an incentive for installation, not for performance. You can also participate in net metering if you have solar, and demand charge management with your storage if you have a demand charge on your commercial bill. So altogether, there is a very good potential for cost savings and revenues from solar and storage in Massachusetts with the addition of storage as an efficiency measure. Next slide, please. So I want to talk for just a moment about our upcoming report. This is going to be all new analysis. The new report does three things. It revises the battery storage cost-benefit ratio for Massachusetts that I showed you earlier based on new information from the utilities. It reviews and critiques the storage program in the efficiency plan. And it, for the first time, as far as we know, that's ever been done, assigns dollar values to 7 non-energy benefits of storage. These are benefits that accrue to society, but you can't, there's no market for them, and so it's very hard to set a dollar value on them, and they were not included in the cost, in the benefit cost ratio calculations that were done for this plan. So these are added benefits that, if they had been included, would have made the cost benefit ratio of storage look even better and would have justified better incentives and a more aggressive storage incentive in this plan. And this report, again, is coming out, we think, in early mid-March at this point. Next slide. Oh, and so before we go on, the non-energy benefits are listed here. So I won't go through the details, but they are avoided power outages, higher property values, avoided fines to the utilities for outages, avoided collection and termination charges to the utility for outages, avoided safety-related emergency calls due to outages, job creation, and less land use for power plants, and that's based on using solar and using storage instead of building new fossil fuel peaker plants, and it's expressed in acres rather than dollars in that case. Next slide, please. So these are the preliminary results, and this is what we will be exploring and explaining in the new report that's coming up, and invite you to check our website. In March, it'll be available. I won't go through all this in detail, but the values for these benefits are listed on the right side of this table, and some of them are quite good. So avoided power outages for commercial industrial customers, that is worth over $15 per kilowatt hour. Higher property values could be worth $510 for multifamily housing and over $5,000 per unit for single-family low-income housing. We have avoided fines worth almost $25 million in 2012. Avoided collections and terminations have a value in the $1–2 range per participant per year. Avoided safety-related emergency calls in the $10 range per participant per year, and job creation in the range of $310,000 per megawatt. And then the land use, as I said, is expressed in acres. You're saving about 12.5 acres per megawatt because storage behind the meter, of course, doesn't have a footprint outside of the existing facility, whereas peaker plants do. Next slide, please. So that's all I have for now. I'm happy to take questions at the end. And again, these links on the slide should bring you to our website, where you can sign up for our newsletters and information. And when that new report comes out, you will get notified. And that's a good way to find out about it. My email is also there. Feel free to email me. Thanks very much.
Great. Thank you so much, Todd. We have quite a few questions rolling in, so we'll get to those at the end. if folks want to keep putting those into the box. Our next speaker is Greg Leventis. Greg's a program manager in the Electricity Markets and Policy Group at Lawrence Berkeley National Lab, where he conducts research and analysis of demand-side efficiency. His focus includes efficiency finance, cost of saving energy, and incentive program design and analysis. And Greg's going to talk to us today about energy service agreements.
Hello, can you hear me?
Can.
Okay, great. Thank you, Jen. I appreciate that. As Jen mentioned, at LBNL, I focus on using financing to pay for energy efficiency. And through this work, I have covered energy service agreements, particularly in a report called Current Practices in Efficiency Financing, which, as you can see at the bottom there, was funded by the Department of Energy's Office of Weatherization and Intergovernmental Programs. Next slide, please. So today I want to give you an overview of what energy service agreements are, mostly focusing on the basics, how they work and key components, their experience to date, and where they fit into the efficiency financing world. And then I'm going to talk a little bit about opportunities and advantages, and finally about some challenges to the model. Next slide, please. I'm going to spend a bit of time here. This is just with the definition of an energy service agreement. And there are a number of different ways I've heard it referred to: energy services agreement, energy savings agreement, efficiency service agreement, ESAs, ESAs. I'm going to call them ESAs, and they are arrangements in which the ESA provider, and I'll sometimes refer to them just as a provider, contracts typically with a non-residential customer, a building owner, or a tenant to provide energy savings. And there are a number of key components to this. So first, the customer is paying the energy energy savings, and generally contracts to provide these at a certain rate per kilowatt hour saved, which should be less than the utility cost per kilowatt hour used. Now, this is important for a few reasons. One, it indicates that the ESA provider is delivering a service. This is what makes it a service agreement and not a loan or a lease. And since the client is paying for a service, they may be able to recognize the payments as an operating expense that could be off balance sheet. And I'll talk more about this later, but do note that you should consult an accounting professional, last slide please, before assuming the appropriate accounting treatment for an energy service agreement or any financing. One slide before, please. Number two, it can insulate customer from risk, which since it means that if no savings are realized, then the customer doesn't have to pay. With a loan or a lease, the customer has to make their payments regardless of the performance of the project. And three, it means that in order to be economically viable for the ESA provider, projects are going to need to be larger, and typically they're looking for projects that are $1 million or more. Now, second key component to the ESA is that the provider owns the measures, like the ones that Jen was discussing earlier. The customer is paying for energy savings and not for the efficiency measure, so it owns, operates, and maintains the efficiency improvements in the building. Third component is that the provider furnishes the financing. And ESCOs generally do not provide financing. The providers do this through a mixture of debt and equity, which is important because taking out a loan, for example, is straight debt, which is less expensive than equity. So the blended rate of the debt and equity together can be a bit more expensive than debt alone. Fourth, the provider manages the contractor, contracts usually with an ESCO, and provides, like I said, operations and maintenance, and also monitoring. And finally, there's also a variation on the ESA, which is the Managed Energy Service Agreement, or MESA, where the provider gets registered as a signer on the client's utility accounts. Sometimes they're including water efficiency, and they manage the payment of those utility bill or bills. Now, I just want to note that ESAs are private sector financing instruments, so they do not require public funds. Next slide, please. So this next slide is a graphic that illustrates the points I just made. The provider contracts with a customer and works with investors and contractors, like an ESCO, for example, to provide energy savings as a service to the customer, who then pays for each kilowatt hour saved. This is a simplified depiction to give you a sense of how it works. What's not included is, if the energy, if the provider engages with the utility, as I mentioned, like in an MESA, then they would be, there would be a utility on here as well. They also may set up a special purpose entity, which is a business that is legally separate from the ESA provider, and it's established to absorb risk, which can make the arrangement a bit more complex. But the bottom line is that from the customer's perspective, they're getting energy savings as a service. So what does this look like? Next slide, please. From the customer's perspective, let's say a company is paying like $30,000 a month in their building or in a number of buildings for electricity, as you see on this leftmost bar here. Then they enter into an ESA, and the building achieves a bill savings of about $10,000 a month. This is the second bar here. And then they pay, say, $7,000 a month for the energy saved. So they have an immediate bill to savings of $3,000 a month. Once the ESA term is over, as you see in the rightmost bar, the customer would get to keep the bulk of those of the total savings. Now, no, these aren't real numbers. They're just for illustration of the concept of how the ESAs can save a customer on their utility bill. So next slide, please. Now, in terms of the context in which ESAs find themselves, what are the alternatives, say, besides cash, that is, to using an ESA for financing? For some context, a study that LB&L did from 2016 looked at the customer-facing financing products that are used to pay for efficiency, and we categorized them as either traditional products, that is loans and leases. They're familiar to most consumers and are used every day to pay for all kinds of goods and services. And then specialized products, which are designed specifically to overcome some of the barriers to efficiency adoption that traditional products might not. And ESAs fit into one of these specialized products categories. So next slide, please, this is a visual layout of those financing products. On the right, you have the specialized products, on-bill arrangements, which allow customers to pay off energy improvements on their utility bill. PACE financing, or property assessed clean energy, you're able to pay off the energy upgrades on your property tax bill. Energy savings performance contracts offer a savings guarantee. But the ESAs, all the way to the right here on the bottom, are the only arrangement that treat energy as a service. Now, on the left-hand side, you have the traditional products, the loans and leases, which are both debt instruments, which raises an important point. This year and next year, the Financial Accounting Standards Board, or FASB, is phasing in new leasing standards. Until now, FASB standards allowed operating leases to be accounted for off the balance sheet, and I'll talk more about this in a minute. But the new standard will no longer allow that, and this may account for the increased interest that the ESA industry participants have noted recently, because ESAs are touted as off-balance sheet service agreements. Next slide, please. In terms of the experience to date, I'm not familiar with any comprehensive sources of data that have tracked the total or annual investments in efficiency that are going through ESAs, but until recently, it seemed like the uptake had been limited. However, Metris Energy, which is an ESA provider, along with Citi, which is a bank, have partnered to provide an ESA for a Fortune 100 technology company. It started with an initial tranche that included several of the company's sites, and it's grown to an arrangement that includes 50 sites and over $60 million of investment. This deal shows that there is increasing interest in ESAs. It shows that ESAs can scale, and it starts to put ESAs on a par with some other financing products. So in the next slide, this is a graphic that comes from a 2016 report that my colleague Jeff Deason and I wrote. Next slide, please. This study quantified the programmatic financing and energy efficiency in 2014. It was a snapshot of that year. As you can see, each box here is one program, and the size of the box represents the relative size of investment in that program. The color categorization is into, as you see on the right here, on-bill, PACE, State Energy Office, revolving loan funds, and other utility financing programs that are not on-bill. As you see in the top left, for example, the big light blue box with $227 million, that's Renovate America's California Residential PACE program. The light orange one below that at $100 million is the Mass Save Heat Loan program. Now, the total volume of this box is about $720 million, and there are about 100 boxes in there, 100 programs that include both residential and non-residential programs. As you can see here, the vast majority of the programs are tiny in the bottom right-hand corner. But the takeaway here is that ESAs seem to have started to make a dent if you compare it to these programs. Metris is only one of probably a dozen firms that are providing ESAs, and although they may be the most successful, they've done over $100 million in investment, which is on par with a number of the larger programs in this chart. Now, the two very important caveats to this, the first one is that Metris's $100 million is over a number of years, even though the bulk of that is probably in the last 2 years or so. And this chart represents just 1 year. But the more important caveat is that in our report, we also covered energy savings performance contracts, which may be the most immediate competitor for ESAs in terms of products, but we didn't include them in this graphic due to data issues. Couldn't match them up. And the ESPCs dwarfed this entire chart. They did about $4.1 billion in investment that year, mostly in public sector. So ESAs in that context are still pretty small, but another perspective could be that they have a lot of room to grow. Which brings us to the opportunities that ESAs offer. So next slide, please. Main ones are, first, the pay for performance. You're paying per kilowatt hour saved, and this incentivizes the provider to get as much savings as possible. So it can match the incentives of the provider and the customer. And then, as I said earlier, it can also provide insulation from project performance risk. ESAs cover both hard and soft project costs, so there are no out-of-pocket costs, which might not be the case with other financing products. Then there's the accounting treatment. I mentioned earlier that ESAs may garner off-balance sheet treatment and can be treated as an operating expense. And the reason this is important is, firms categorize their expenses into capital expenses and operating expenses, and it can be easier to get an efficiency project done if it's an operating expense because, one, the decision process for capital expenses can take a lot longer, like a year or more. And two, if it were a capital expense, it may have to compete with other opportunities that management might see as more core to the business priorities. And then in terms of the balance sheet, firm's balance sheet lists its assets and liabilities. And liabilities include long-term debt in order to show the company's financial position. And if an ESA is accounted for off the balance sheet, then it's not recognized as long-term debt. So the balance sheet reflects a better financial position for the company, all other things being equal. And it could also free up room for the firm to take on debt for other priorities. Finally, building owners and tenants may value the convenience of an ESA. You don't have to go looking for financing. You don't have to manage an ESCO. They know that their incentives are aligned in terms of getting the most savings out of the project. And under a managed energy savings agreement, they might not even have to worry about paying the utility bill. Next slide, please. So the challenges for ESAs basically all have to do with understanding the arrangements from my perspective. The first is that they can be complex. There are a lot of players involved, a lot of interactions involved, and the payment mechanism might not be intuitive. The second is that it may be difficult to compare other financing products since there's not an explicit interest rate, and the pay-for-performance nature of the arrangement doesn't lend itself to an apples-to-apples comparison with other financing products. It's good in some respects, but not necessarily for comparing it with other products. And finally, I've seen ESAs referred to as a PPA for energy efficiency. But one important difference is that with a PPA, the kilowatt hour generated can be measured and charged for. But as my friend Steve Schiller likes to say, energy savings can't be measured, they can only be estimated. And how one goes about estimating those energy savings that are going to be the basis for payments could be a point of contention. So open and transparent protocols and agreements on how savings are going to be estimated are really crucial. So the takeaway here is that ESAs have a great need for education of market participants. I'm going to leave it there. Next slide, please. I just wanted to thank you all and say if you have any questions on the presentation afterwards, please feel free to reach out to me. And be sure to check out the many, many other resources that LDNL and the Electricity Markets and Policy Group have on efficiency financing, ESCOs and ESPCs, energy efficiency more generally, renewables, and a whole lot more. So thank you very much.
Thanks so much, Greg. So we have quite a few questions here for Todd and Greg, so I think I'll just go back and forth and have questions for each of you in order. We can take turns. So one question for you, Todd. One simple question while we get to the others. I think several people were interested in what the source was for the electric efficiency program spending per capita chart that you showed in your presentation.
Are you asking what the source was for the program budget, or are you asking what how we came to the amount that a customer would get? I'm not sure I understand your question.
Well, I'm not sure. That's what the folks have asked. I think maybe they want to know where that data came from, and maybe where you collected that data, if it's from your own report or if it's from another report, where that can be found.
Okay. Well, the program data came from filings in the docket in Massachusetts, the DPU docket, and from the DPU order that was issued last week. The calculations having to do with the customer, potential customer payments that the incentive would translate to, we did based on the rates and the way that the program is designed in terms of performance incentives. If you're asking about the values for the different energy storage benefits, those were calculated based on a lot of variables by an economist that we contracted. The report that I showed that we published in July is available on our website, and you're welcome to go download that and look at it and see where how those values were calculated. The new report will be out in a month or less, and we at that time, you can look and see how those values are calculated.
Okay, great. One more substantive question for you, Todd. Did you consider evaluating the emission benefits as one of the non-energy benefits of storage?
Yeah, that's a very good question. The reason that's not included as a non-energy benefit is because Massachusetts includes emissions benefits in the energy benefits of its efficiency measures. And that wasn't clear. I had the same question. So I apologize that wasn't made clear, but there are essentially energy benefits and non-energy benefits for each measure. And so in the case of energy storage, battery storage, the cost-benefit ratio that was used in putting this incentive in place included all the energy benefits, and that includes emissions reductions. And those are based in this case on shifting load from peak periods to non-peak periods, and thereby changing the mix in the state's energy generation portfolio. The non-energy benefits that we analyzed and will be reporting on very soon are everything other than what's included in the energy benefits. So in this case, the value of reduced emissions is included in the existing cost-benefit ratio as an energy benefit. Some other states probably would look at it differently, and it would then maybe be included as a non-energy benefit. And I agree that that would make sense, but that's not how Massachusetts chooses to do it.
Great, thanks, Todd. So, Greg, we have a couple of people asking if you could elaborate a little bit on the differences between ESAs and ESPCs.
Sure, and I'm not an expert on ESPCs, but the ESPCs are contracts with an ESCO, an energy service company. The energy service companies, I would say that there are a few major differences. The first that comes to mind for me is that energy service companies do not furnish financing. So you would go contract with an energy service company, but then you would have to separately find financing for that project. The other thing is that the energy service agreements are based on you are paying per kilowatt hour saved, whereas in the energy service, in the energy savings performance contract of the ESPCs, you often can get a guarantee for a certain amount of savings, but you're not paying for the savings directly. And the third difference, if I understand it correctly, is that with the ESPCs, the customer would actually own the efficiency measures, whereas in the ESA they do not. The ESA provider is the owner of those measures.
Okay, great. I think that really helps. One other question for you, Greg. Can tenants take advantage of ESAs, and are you aware of any successful examples of tenants engaging in an ESA arrangement?
Tenants can. I've spoken with some ESA providers that say that they've had multiple. I believe that one example I talked about with Metris, I believe in most of those cases they are tenants in their buildings. They have said that in each of the cases they've gotten express consent from the building owner. But yes, that is a good point to bring up, that they have in fact successfully done that with tenants in a number of places.
All right. Well, great. Thank you so much. We're out of time. We're right at the 1 o'clock mark. I note that both Greg and Todd have provided their contact information on their slides. So if folks have further questions or want to follow up on questions we weren't able to get to, I think you can direct those questions to each of the speakers. And also feel free to contact me with any questions that you might have about ACEEE's work in any of these areas. I want to thank everyone for joining the webinar today. A special thanks to our presenters, but for everyone for taking out time from their day to share a little bit with us. Within the next day, we'll send out a link to the recording of today's event, and you'll also be able to find it on ACEEE's YouTube page. You can find the briefs on ACEEE's website. So have a great rest of your day, and we look forward to hearing from you again as we continue our webinar series. Thank you so much.
Thank you.